Hello everyone, let's go faster. In this video I will show you what happens with the idea if you decide to change the number of teeth on the sprocket. If you want to increase it or decrease it, we'll see if indeed makes the bike go faster. This applies to motorcycles as well as bicycles, because they have the same kind of roller teeth, the same roller change, the same kinds of sprockets with the same kind of teeth on them. Everything is just lighter gauge. ATVs, dirt bikes as well. So to a lesser degree, chainsaws, and in cars you got a chain that drives your camshaft. It also applies what happens if you mess with the numbers and change the number of teeth on the sprockets. Will it indeed make your vehicle go faster? Okay, I have a really simple way to illustrate this one and sort this one out. For this we need a drive sprocket. This is your drive sprocket on a motorcycle, and this one is your driven sprocket. Okay, now these ones have way too many teeth. I'm gonna show you some super simple example, and it's gonna be crystal clear what happens when you change the number of teeth up or down. Just pretend that on the drive sprocket you've got 4 teeth. Okay, it's ridiculous, but just go with this one. 4 teeth on the drive sprocket, and on the driven one you've got 8. Now, how many times does the drive sprocket need to turn around to make the driven sprocket turn around once? The drive sprocket would need to go around twice to make the driven sprocket go around once, because this one has 4 teeth, this one has 8 teeth, and if you visualize it, it engages like so, and eventually the 4 teeth would need to go around twice. Now, if this had 8 teeth and this had 8 teeth, then the drive and driven sprocket, the number of turns the drive sprocket makes is exactly the same as the number of turns the driven sprocket makes. But if this one has only 4 teeth, this one has to go around twice to make this one turn once. Okay, that makes sense? Now, in terms of math, you can write it up in a fraction like that, 4/8. That's your drive ratio. Drive ratio. Now, 4/8, that's a fraction that can be simplified and brought to lower terms. So we're going to write up an equivalent fraction here. How about 1/2? And it's got a decimal equivalent, which is 0.5. Because you punch it into your calculator, 1 divided by 2, and you're going to see 0.5 on the display. Now, I'm gonna write another 0 there. It's the same amount. Now just pretend this is 50 cents, okay? And work with that one. 0.5 or 0.50, it's the same thing. Haven't changed anything, I just added a spare 0 there. Now, think about this one. The drive sprocket still has 4 teeth on it, and I'm just gonna change one thing at a time so you can see the changes. And now the driven sprocket will have 12 teeth on it. Now, I'm not gonna draw 12 hairlines on this one to represent the sprockets, but just go with this one. So now you have more teeth on the driven sprocket than before. So if I write up a fraction, it's 4 divided by 12, which is the same as 1/3, which is the same as 0.333, and it's a repeating infinite decimal. Now, your bike will slow down if you put more teeth on the driven sprocket. How do I know? Think about this one. The drive sprocket in this first example has to go around twice to make the wheel turn around once. But if you have 12 teeth on the wheel sprocket and 4 teeth on the engine sprocket, the engine sprocket that's mounted, damn trucks, that's mounted on the transmission shaft coming out of the transmission. This one, the transmission shaft has to turn around 3 times to make the rear wheel go around once. Okay, so you have a 3-to-1 ratio or a 1-to-3 ratio depending on which way you are looking at it. That's what's shown here in this number. This 0.5 or half means that the wheel is going half as fast as your engine. Here, this number is showing you that the wheel is going 1/3 as fast as the engine. If the wheel is going 1/3 as fast, and here a wheel is going half as fast, you can see that the speed at the rear wheel dropped down. It used to be 0.5, but now it's 0.3. Just ignore this little digit there for now, and you can see it dropped down by 0.2. Okay, you can see that the rear wheel is going slower. To verify this idea, we've got the same drive sprocket, and instead of 12 teeth we're gonna have 16 teeth on the wheel sprocket. Now, to have the wheel sprocket turn around, or the whole rear wheel turn around once, the engine, the transmission shaft and the engine sprocket would need to go around 4 times, because it's got only 4 teeth and this one has 16 teeth. This one needs to turn around 4 times to make the rear wheel turn around once. Okay, if this is the original factory setup and this is a modification, then you can see that we doubled the number of teeth on the driven sprocket, and it slows the engine down by half. So if your motorcycle is doing, say, 200 km/h top speed at this sprocket arrangement, it will only do 100 km/h speed tops, because the engine sprocket has to turn around only twice to make the rear wheel go around once, and here the engine sprocket needs to go around 4 times to make the rear wheel go around once. The numbers will tell you the same story. 4/16 is the same as 1/4. Equivalent fraction, standard procedure, is the same as 0.25 in decimal. Now, just pretend is 0.25 is a quarter, as in money. Think money. A quarter and half a dollar. You know that a quarter is half of 50 cents. So you cut your speed in half. So if your motorcycle was able to do 200 clicks, with more teeth it's gonna be doing only 100 clicks top speed. Now, in the meanwhile, while the speed drops down, the torque increases. So if you want to do dirt biking and have more control, you want to do more teeth on the engine, on the wheel sprocket, okay, because the torque will increase, the engine speed will decrease. We just calculated that the engine speed from 0.5 to drop down to 0.25. This is your drive ratio, and your engine speed drop down by half as much, or half of what it was before. Your torque will increase, so you can do wheelies easier and better. One more change is our concept acceleration. Acceleration. Your bike will accelerate faster because the engine sprocket, the engine is not getting any stronger just because you change the number of teeth on the sprockets. Okay, so the engine will have the same power, and the same power will will accelerate the same mass on the motorcycle better if it's got more teeth on the wheel sprocket. Okay, that's another story in physics. Just go with that one. Your acceleration will improve. Now, if you change the number of teeth on the drive sprocket, let's see briefly what happens. So instead of 4, I'm gonna pick 6. Let's go with 6 teeth, and we've got 12 at the back. Okay, and we are gonna contrasting it with that arrangement there, because 12 kind of works with 6. So now you increased, this is your baseline, 4 and 12, and now you increased the drive sprocket to have 6 teeth on it. Now you have a drive ratio on 6 over 12. 6 over 12, equivalent fraction of it is 1 over 2, is the same as 0.5. So now you have a drive ratio that was just as good as 4 over 8, but now you have 6 and 12 teeth. Okay, so if you have 12 teeth at the back, and you add more teeth at the engine sprocket, at the drive sprocket, it's gonna make your bike go faster. If this was your original performance of the vehicle, 0.3 for drive ratio, I'm just gonna ignore that repeating decimalness of it. We went up from 0.3 to 0.5. I say we very nearly almost doubled from 0.3. I know double of 0.3 would be 0.6, but I'm just rounding off. Okay, so work with me on this one. So we very nearly almost doubled the speed of the bike by adding more teeth to the drive sprocket. So the bike does go faster. Now let's verify that one. What happens if we say, this is ridiculous, what happens if you only have two teeth on the drive sprocket? Okay, this is nobody makes a sprocket with 2 teeth, but just work with the numbers here. And we have 12 sprockets on the driven sprocket. Okay, it's giving us a fraction of 2 over 12, which is the same as 1 over 6, and the decimal equivalent of 1 over 6, oh I don't know, 1 over 6 is that number, 0.16, and the 6 is repeating. So what happened? We went from 4 to 12 to 6 to 12, and we doubled the speed. But if we go from 4 to 12 to 2 to 12, we halved the speed. At 4 to 12 we had a drive ratio of 0.33, and now the drive ratio dropped down to 0.16. Half of 0.33 is 0.16. I'm just rounding again, okay? Just work with me on this one. So we halved the engine speed by dropping the number of teeth on the drive sprocket. So this arrangement increased speed. This arrangement increased speed, but this one slowed down. This arrangement slows down the bike. Eventually, when you look at these drive ratios, you will find one drive ratio that will slightly make your bike go faster. But when you do make your bike go faster, there's a couple of things that happens. So the speed, let's see, wrong line here. The speed does go up, but the torque will drop down. So that means that the acceleration, I'm just going to abbreviate, the acceleration is going to drop down as well. It's going to take, the bike is going to go faster, because only if you have 6 teeth at the front, 6 teeth only need to turn around twice to make the rear wheel go around once. And if this was the original arrangement where it had to go around 3 times to make the rear wheel go around once, so it's a 3-to-1 ratio. Now it's only a 2-to-1 ratio. So the speed does go up, but the torque and the acceleration goes down. It will take more time to accelerate the bike from a stop line or from a finish line. And if you're looking for a peppy ride where highway merging is not a problem, this is a bad change to do. Okay, your top highway speed will be higher, but if you do a lot of merging, you're gonna be merging slower. Now let's look at real numbers finally. Okay, these were real numbers, but I'm thinking about these ones. So if you have 15 teeth on the drive sprocket and 45 on the driven sprocket, there's your drive ratio. 15 over 45 is 15 over 45 equals that number. Let's pretend that this is your factory original setting. Let's see what happens if you change the design. Instead of 15, you want to do, instead of 45 teeth, you want to go up to, you want to go down to 42 teeth because you want to make your bike go faster. But how much faster will it make your bike? Because no manufacturer sells sprocket with 4 teeth or 6 or 16 or whatever. Okay, so how much will my bike go faster? How much faster? We established that if we drop the number of teeth on the sprocket, it will go faster on the driven sprocket. So let's see the numbers. 15 over 42 equals that number. That number. So we do go faster, and if this is the original amount, then let's see, divided by, other way around, divided by that number, we go, wow, 6% faster. Just ignore the 1, and that's how we make a percentage there. Okay, it's 6% faster. Okay, how did I do this calculation? It was the new amount divided by the old amount divided by the 0.33. Let me do it again. 0.35 divided by 0.33 there, and you're just looking at, and you subtract 1 from it there, and you times that by 100 there. 6%, 6.06%, 6.06. Just ignore everything else, just look at the whole number. 6% faster. Okay, that means that if your top speed was 200 kilometers per hour, now your new top speed will be 212 kilometers per hour. Okay, what happens if you keep the 42 teeth at the rear and decide to increase the number of teeth on the engine and go 17 teeth? How much is that gonna make the bike go faster? We'll go 17 over 40. Let's see, 17 over 42 equals that number. And here is our formula. That was that's the new number, 0.4, and the old number was this one. And let's see what we get out of it. 0.33 divided by 0.4 equals, I did it the other way around. 0.4 divided by 0.33 equals that number, minus the 1 equals, sorry guys, one last time. divided by 0.3. Okay, I'm gonna cut to the chase. It's gonna make your bike go 33% faster. You can see the numbers, you can do the math. This sprocket arrangement will make your bike go 33% faster. So if your top speed used to be 200 clicks, now your new top speed will be 266 kilometers per hour. Yeah, in theory. Because remember, your bike, your engine doesn't get any stronger, and wind resistance is significantly gonna hold you back. So in theory, you might be able to reach 266 kilometers per hour speed, but we're not compensating for the increased amount of wind resistance, which is increasing on an exponential scale. So, but just for a theory, it would make your bike go 33% faster. So that's how you can look at these numbers that the manufacturers list in their catalogs, and how many teeth you want for your sprockets. But remember, if the calculations make your bike go faster, that also means that it will accelerate slower, and the torque of the engine will also drop. It's gonna be dragging more and gonna feel underpowered. Okay, so bottom line, the manufacturers who make the sprockets for your specific make and model, they don't have a whole lot of changes that you can do with the number of teeth, because if you wanted to do this 33% radical increase in speed, it would make your bike accelerate at a very, very sluggish speed, and that's just not good for merging with traffic. Think about it in terms of, it makes your bike 33% faster, but also 33% slower to accelerate. So that's just in general traffic, or even in racing, it's not really acceptable. Okay, so that's how you make sense out of these numbers, and that's why sprocket manufacturers don't give you a whole lot of choice, because what they are basically saying, don't change the design, don't mess with it much. You can go 1 or 2 teeth up or down, and that's pretty much it. But even that will significantly change the behavior of your bike.